everyone! In this video we're going to go over problem B on page 47. 1 plus tangent x squared equals 4. Before you watch this video, I would highly recommend you review problem C, tangent theta equals the square root of 3. If you haven't already watched problem C, I would highly recommend you watch problem C before watching this problem, because we're going to use some of what we learned in problem C in order to answer problem B. Okay, so let's get started. So I'm actually going to turn this over because I know I'm definitely going to run out of space if I try to do this problem on this page. So I'm going to flip over the page to do problem B. Okay, so B, again, is 1 plus tangent x squared equals 4. So the first thing I'm going to do again is replace tangent x with a variable. I'll just call it x like we did before, because it's going to be a lot easier, again, to solve this equation if we just use a variable. So for the moment, we're going to call tangent x. So if x equals tangent x. And again, I'll color this x red, just so we don't mix it up with that x, because that's an angle, and this is just what we're calling tangent. Okay, so let's go ahead and rewrite this problem using x instead of tangent. So it's going to be 1 plus, since we had tangent x squared, our x should be squared, because x is now tangent. So we have 1 plus x squared equals 4. Okay, now again, we have an equation that we know how to solve. We want to get x by itself. To do that, we're going to want to subtract 1 on both sides. So let's go ahead and subtract 1. 1 minus 1 is 0. It just cancels out like what we wanted. We can bring down our x squared. That gives us x squared over here equal to 4 minus 1 is going to be 3. Okay, now we have x squared equals 3. Again, to get a single x, to get rid of the squared, we want to square root the x squared. So I'm going to take the square root of x squared. And what we do to one side of the equation, we have to do to the other side. So we need to take the square root of 3 as well. And again, when we take the square root of x squared, remember that our index on the square root is going to be 2. X squared can be rewritten as x times x. We're looking for a pair. We got one here. So x just comes out of the square root. And if you recognized x squared as a perfect square, you could have just took x out immediately. Okay, so x equals, the only thing that goes into 3 is 3 times 1. So 3 is not going to have a pair, so we can just leave it alone. Bring it down as the square root of 3. But remember, when we take the square root of a number, when we're solving for a variable squared, it becomes positive and negative. So x equals positive and negative square root of 3. Okay, so now remember that x was tangent. So I'm going to go ahead and put tangent back in for x in order to finish this problem. So x is now tangent, so tangent x equals plus and minus the square root of 3. Again, all I did was put tangent back in for x, so we can solve this. Okay, so now tangent equals plus and minus the square root of 3. In other words, we have tangent of x equal to positive square root of 3. And we have tangent of x equal to negative square root of 3. And we know how to solve these kind of problems, because now we just have a trig function equal to a value. That's what we were trying to get. So now it's just asking us at what angle is tangent equal to positive square root of 3? And at what angle is tangent equal to negative square root of 3? And remember that tangent is defined as sine over cosine, as we saw in part C. Tangent is equal to sine over cosine, or our y-coordinate or our x-coordinate. So let's go ahead and write that here. Tangent x equals sine over cosine. Now, this problem might look familiar to you. Tangent of x equals square root of 3. We actually did that one already in problem C. Tangent of theta equals square root of 3. If you recall from problem C, we figured out that x was equal to 60 degrees, because sine divided by cosine gave us square root of 3, positive square root of 3. So x was 60 degrees, which is the same thing as pi over 3 radians. And in problem C, we figured out that tangent was also equal to 240 degrees, because sine divided by cosine was, again, positive square root of 3, since a negative divided by negative gave us a positive. So x was equal to 240 degrees, which was the same thing as 4 pi over 3 radians. Again, we figured this out on problem C. Okay, now we also need to figure out in this problem where tangent is equal to negative square root of 3. So it's going to be somewhat similar to what we did here. So let's see. Tangent can be negative in two ways, again. If sine is negative and cosine is positive, because a negative divided by a positive gives us a negative number. Or if sine is positive and cosine is negative, because a positive divided by a negative gives us a negative number. And we want to know where tangent will equal the square root of 3, but negative square root of 3 this time. So let's look at the case 1 first. Where will sine be negative and cosine be positive? Well, we know that sine is negative on the bottom half of the unit circle, and we know that cosine is positive on the right side of the unit circle. So that tells us we must be in quadrant 4, where sine is negative and cosine is positive. Now we know that when we have the square root of 3 over 2 divided by 1/2, we get square root of 3, because that's what we saw in problem C. So again, if we find that combination of coordinates, we should get the square root of 3, which is right here. Negative square root of 3 over 2 divided by 1/2 should give us negative square root of 3 this time, because a negative number divided by a positive number gives us a negative number. So that tells us that at 300 degrees, or 5 pi over 3 radians, we should get negative square root of 3. So x, or our angle, equals 300 degrees, or 5 pi over 3 radians. Same thing. Okay. Now similarly, we can find the same combination somewhere else in the unit circle. So where will sine be positive and cosine be negative? We know that sine is positive in the upper half of the unit circle, and we know that cosine is negative as we go to the left. That tells us we must be in quadrant 2, because sine is positive and cosine is negative only in quadrant 2. Now again, if we can find the same coordinates for sine and cosine, then we can get the negative square root of 3. We see that sine is the square root of 3 over 2, positive square root of 3 over 2, like we want here, and cosine is negative 1/2 here. That tells us that 120 degrees, when we divide sine over cosine, or square root of 3 over 2, by negative 1/2, we should also get negative square root of 3. So let's just go ahead and write that as our answer. So that tells us our x equals 120 degrees, or 2 pi over 3 radians. So we actually end up getting 4 answers here. Again, because at 60 degrees, or pi over 3 radians, tangent was positive square root of 3, and at 240 degrees, or 4 pi over 3 radians, tangent was also positive square root of 3. And then we just figured out at 300 degrees, or 5 pi over 3 radians, tangent is negative square root of 3. And at 120 degrees, or 2 pi over 3 radians, tangent is also negative square root of 3. Okay, so that's problem B. In the next video, I'll go over problem C on page 47. Until then, see ya.